my KCET 2025 aspirants. So in today's class, we are going to do the one shot of the chapter, the first chapter, that is some basic concepts of chemistry. So here the three important things that you should be knowing is stoichiometry, mole concept and your empirical formula calculation. Okay, so we'll be discussing that in detail and we'll also be covering some other topics that is there in this chapter. Let's get started without any delay. So in this video, first we will see the laws of chemical combination. 5 laws are there: Dalton's atomic theory, atomic and molecular mass, mole concept, percentage composition and stoichiometry. Okay, so let's see the first one. Weightage, you can see almost it is 0 some years, but yeah, mole concept is something which can be used everywhere, so you should be knowing that. So coming to the first thing, that is laws of chemical combination, Dalton's atomic theory, atomic mass and molecular mass. So we will explain all these things in the upcoming lectures. So first is your law of conservation of mass, and this says that mass cannot be created nor neither be destroyed, means the total mass of the reactant will always be equal to the total mass of the product. So I can say total so I can say like this, that total mass of the reactants is equal to the total mass of the products. Okay, next, law of definite proportion. This says that atoms always combine in a fixed ratio by mass, means if you are taking hydrogen and oxygen to form water, the ratio of hydrogen and oxygen will always be 2/16 or 1/8. Next, we have law of multiple proportions. Now, if two elements can combine to form more than one element or compound, the masses of the one element that combines with a fixed mass of the other element are in the ratio of small whole numbers. Let's understand this one. So, for example, if I take carbon and oxygen and they are combining to give you CO and CO2. Now, what is the mass of carbon? This is 12. And mass of oxygen, it is 16. Similarly, mass of carbon is 12 and mass of oxygen is 32. Now you can see that carbon have a fixed mass here, right? Oxygen mass is, we have to take the ratio. So mass of oxygen in CO divided by mass of oxygen in CO2, that is 16/32, and that is equal to 1:2. Clear? Next, we will see Gay-Lussac's law. It says that when gases will combine in a reaction, they will also do it in a fixed ratio as compared to law of definite proportion. Avogadro's law, it says that if you have taken equal volume of gases, okay, if you have taken equal volume of gases at the same temperature and pressure, then they will contain same number of molecules. Okay, equal volume will contain same number of molecules. Okay, now we'll come to Dalton's theory. Dalton says that matter is made up of small particles or fundamental particles, indivisible particles called as atoms. Okay, now atoms of one element will have identical properties including the masses and everything, and atoms of different element will have different properties. Now compounds are formed when atoms will of two different elements will combine, we will get compounds, and these atoms should combine in a fixed ratio. Now chemical reactions involves the reorganization of atoms. These are neither created nor destroyed in a chemical reaction. So Dalton also was agreeing with the law of conservation of mass. Clear? Next, we have here atomic mass. So you just very simple, you should no need to remember these all definitions. Atomic mass is the mass of one atom, okay, of any element. Mass of one atom of element is called atomic mass. Its unit is atomic mass unit, okay, atomic mass unit, and the value of this one is mu. Okay, now average atomic mass, how do we calculate, or what is the need of average atomic mass? So when we certain elements, we have studied in the structure of atom chapter that certain elements can behave or can exist in the form of isotopes, right? So carbon 12 is also present, carbon 13 is also present. So what is the actual mass of carbon? So in that case, we calculate the average atomic mass of all the isotopes. What is the formula here? Suppose you have isotope 1, okay, and isotope 2. The percentage of isotope 1 is P1 and here it is P1. Mass of isotope 1 is M1 and here it is M2. So what is the average atomic mass formula? I'll write here average atomic mass. Formula will be P1 M1 plus P2 M2 divided by 100. P1 M1 plus P2 M2 divided by 100. Okay. Next, if you see molecular mass, so molecular mass is the mass of one molecule. Like for example, if I have water, okay, so in this I have mass hydrogen plus hydrogen and oxygen, right? Hydrogen mass is 1, hydrogen mass is 1, oxygen mass is 16, so I will get 18. Okay. Next, formula mass, it is same as molecular mass, but when you talk in terms of ionic compounds, for example NaCl, it is an ionic compound, it is actually a formula, right? Na plus and Cl minus is the formula. So Na mass is 23, chlorine is 35.5, so I will get here 58.5. okay, clear? Next, we'll understand mole concept, very important. So you should understand here that 1 mole of anything, 1 mole of a substance means 6.02 into 10 to the power of 23 particles, and this 6.02 into 10 to the power of 23 particles is nothing, or it is called as Avogadro number, okay, and denoted by Na. Okay, so now we have yes, so now what happens, this amount of substance, how much substance is present, we can denote it in various forms. For example, we can tell mass, we can tell moles, we can tell volume, we can tell number of particles. So all these forms can be interconvertible to each other, means if you know molecules you can know mass, if you know mass you can calculate volume, if you have volume you can calculate particles, everything can be interconvertible. So that is where questions are asked, and that how to do, let me tell you. So I will do this again. Okay, so first of all, suppose I have mass, okay, and I have this side number of particles, and this side I have volume, okay, and in the center it should be your moles. Okay, so that means suppose if I want to convert mass to number of particles, it should go through moles. If I want to calculate number of particles to mass, it should go through moles. Volume to number of particles, through moles. Volume to number mass, through moles. So everywhere this is the central junction from where each conversion can take place. Now for example, so if I want to calculate moles to mass, okay, so you have to just multiply with molecular mass. Okay, like for example, molecular mass of water is 16 and 18, sorry, molecular mass of water is 18, 1 mole mass is 18, 2 moles mass will be 2 into 18, that is 36. Similarly, mass to moles, if it is given, divide by molar mass. Okay, moles to number of particles into Avogadro number, number of moles to number of particles to moles, divide by Avogadro number. Then moles to volume 22.4 liter and volume to moles divided by 22.4 liter. So these conversion you can do. Suppose number of particles is given, you want to find mass, first convert it into moles, then multiply molar mass to get your mass. So this type of conversions you can easily do. Next we'll see some percentage composition, how to find out mass percentage composition. So that is mass of that element in the compound divided by the total mass of the compound into 100. Okay, so for example, if I want to calculate the mass percentage of elements present in sodium sulfate, okay, so I'll just give an example. What is the total mass of this one? Sodium mass is 23, 2 sodiums are there, so 2 into 23, right? Then I have one sulfur, okay, then I have 4 into 16, so it is 46 plus 32 plus 64, so 4, 5, 6 plus 12, 4, 3, 7, 8 plus 6, 14, 142 is there, right? So I have now, if I want to calculate the percentage of sodium, that will be equal to what? 46 by 142, okay, total mass of sodium divided by the total mass into 100. If you want to calculate the percentage of sulfur, it is 32 by 142, okay, just take this calculation, I have done it correct or not. 6 plus 4, 10, 12, I'll get here 6 plus 3, 9, 10, 14. Yes, I think it is correct, but this is the formula. But once again, you check the calculation because my calculations are little bit on the off side. Okay, 64 into 142 into 100. Okay, so if I solve this, I'll be getting these values. Okay. Next, we'll discuss something very important, that is empirical formula and molecular formula. So now see, empirical formula will tell you the smallest ratio of the atoms present in a compound. So for example, if I have C6H12 and O6, so what is the ratio of the atoms present here? C, I can cancel with all CH2O. So this is the simplest ratio of the atoms present in a compound. This is called as your empirical formula, and the actual formula of the compound is your molecular formula. Now how do we find the empirical formula of a compound? So I'll do a question, but let me tell you how to find the empirical formula. So we need to draw a table. Okay, on the first column you have to write the element name. Then in the question you will be given the percentage, so percentage. Then here you have to calculate the number of moles. So whatever percentage is given divided by the molar mass, you will get number of moles. Then here it is simple ratio, okay, and here it is whole number ratio. Okay, so now for example I'll take suppose carbon is present in an element 36%, okay, and hydrogen is present, sorry, not like this, one second here. Okay, so for example in some element carbon is present 72% and hydrogen will be 28%, right? Now what is the number of moles of carbon here? So carbon molar mass is 12, so 72 divided by 12, that is 6, and this is 28 divided by 1, that is 28. Now when you want to find the simple ratio, you have to divide the smallest number with both of them. So 6 is the smallest number, so 6 by 6 I will get 1, and 28 divided by 6 I think I can get 6 4s are 24, again 40, so 6 6 are 36, so 4.6 I will get. Right, now you see this is not a whole number, right? So what I can do, I can multiply with some number so that it becomes a whole number. If I just multiply this with 2, so I'll get 2, both the numbers should be multiplied with the same number, right? So I'll get 9.2. Now 9.2 I can round it, approximate it to 9. Okay, so then what is the empirical formula of this compound? C2H9. So this is just an example how to solve it. First percentage will be given, take the number of moles, divide the number of moles with the smallest atom. So the smallest value should be divided in both the cases, and then you can calculate the whole number ratio. Okay. Next we have a pure compound contains 2.4 gram of this one, and this many grams of hydrogen, and this many grams or moles of oxygen atoms. Its empirical formula is, okay, so we can directly do first how to do. See, I have elements carbon, hydrogen and oxygen. I have to first find out their number of moles. Here percentage is not given, directly number of moles are there, so that is fine, we can directly calculate the number of moles. 2.4 gram of carbon, right? So what is the mass of carbon here? 2.4 gram. Hydrogen 1.2 into 10 to the power of 23 atoms are given, and oxygen 0.2 moles are given. Then what is the number of moles in each of them? So for carbon, given mass by molar mass, so 2.4 divided by 12, so that is 0.2. Then 6 into, so this is also 0.2 because I have to divide by 6 by 10 to the power of 23, and this is also 0.2. So if I divide the smallest number by all of them, I will get 111. So the empirical formula is CH4, sorry, not this one, CHO, that is option number D. Okay. Next, here we have a question. A compound consists of 52.17% of carbon, 13.07% of hydrogen and 34.78% of oxygen. Find the molecular formula if the empirical molecular weight of the compound is 46 gram. So here you have to find the empirical formula as well as the molecular formula. So first let us start with our basic step, C, H and O, right? So first, what is the percentage of carbon? So I'll just put one line more here. Carbon percentage is 52.17. Okay. Next I have hydrogen is 13.04 and oxygen is 34.78. Okay. Next I have to calculate here number of moles. So 52.17 divided by 12 we have to do. So I will get 4 point something, right? So let me do a small division quickly here. So I have 12 4s are 48, so 4, 1 is carried, again 12 3s are I can take 36, so 5 and 7, 12 4s are 48 again, so 4.34 I got. Hydrogen you will get same 13.04, and here for oxygen I have For oxygen, what I can do is, you see we have been given with 34.78, right, 34.78. So 34.78 divided by 16. So 16 2s are 32, then I get 2 7 27, then again 16 1s are 16, 11 118, then I have 16, 9 6 are 54, 9 is more, 8 6 are 48, 8 1s are 8 plus 4 12, 8 is also more, 7 I think, 7 6 are 42, 7 1s are 7 plus 4 11. Okay, so 2.17. Okay, so now what is the smallest number out of this? This is the smallest number. We can divide that to all of them. So I can see that this is exactly divisible 2 and 1. Now 13.04, okay, and 2.17. Just a minute. So this can be written as 1304 divided by 217, right? So 2 7s are 14. So with 2 I will get 434, which is very less. Up 5 of 7s are 35, with 5 also it will do 6 7s are 42. I think with 6 I can take 6 7s are 42, 4 6 1s are 6 plus 4 10, 6 2s are 12 plus 1 13. Okay, so I'll get almost around 6. Clear? So this is very near. So what will be my empirical formula? C2H6 and O. Okay, I hope this is clear. Okay, next what I can do? Okay, so I have got by this time the empirical formula as C2H6 and O. Now what is empirical formula mass? Empirical formula mass, so it is 12 2s are 24 plus 6 plus 16. That will give me 12 2s are 24, 24 plus 6 30, 30 plus 16 is 46. Okay, now what you have to do is, you have to so this is your empirical formula mass. Now molecular formula is equal to empirical formula into N. Okay, empirical formula into N. And how to find N? N is nothing but empirical formula mass, N is molecular mass, okay, divided by empirical formula mass. Now molecular mass is 46, empirical mass is also 46, so N value is 1. So I can get C2H6O into 1, that is C2H6O. So here this option is correct, C2H6O. You can see how it is written, C2H6 and O, that is option number A. Okay, now okay, now coming to something called as stoichiometry, very important. So stoichiometry is used for two purposes. Okay, stoichiometry is used to calculate how much product will form when a certain amount of reactant is reacting. Okay, two reactants are reacting, then how much product will form. If such type of calculations we have to do, we need the help of stoichiometry. Okay, or how much reactant is needed to produce a certain amount of product. Suppose I am doing, like for example, you are arranging a party, right, and you need 100 puris to prepare. So for that 100 puris, how much atta you need, right, how much wheat you need, that is a calculation, reverse calculation. Similarly for certain industry, for example, for certain industry we need this much amount of ammonia. So for that how much reactant should be there. So that type of back calculation also we use stoichiometry. Okay, and in stoichiometry it is very important that balanced equation should be there. Your equation must be balanced. Okay, so for example, you can see here, if I want to calculate that in this CH4 plus 2O2 gives CO2 plus 2H2, right, this is a balanced equation. So this equation tells me what? 1 mole of CH4 reacts with 2 mole of O2, right? 1 mole of CH4 reacts with 2 moles of O2. That's the first thing. I can also talk the same thing in terms of mass. Now CH4 mass is what? 12 plus 4 16. So 16 gram of CH4 reacts with 16 into 2 32 gram of O2. Right? You can talk in terms of mass as well. Okay, clear? Now we will see one question here. 4HCl plus MnO2 gives 2H2O plus MnCl2 plus Cl2. How many grams of HCl react with, how many grams of HCl reacts with 5 gram of manganese dioxide? Okay, so for this type of question, very simple one. So I can say from the balanced equation that 1 4 moles of HCl, 4 mole of HCl reacts with 1 mole of MnO2. Okay. Now 1 mole of HCl mass is how much? 36.5 gram. Okay, 36.5 gram of HCl will react with how many mass of MnO2? So for that we need manganese oxide molar mass. So molar mass of Mn is 55, okay, and O2 is 32, right? So I can 5 plus 6, 7, 87. So 1 mole of, 4 moles, right? 4 moles of HCl reacts with 1 mole of MnO2, that is 87 gram of MnO2. Now I want to calculate for 5 gram of manganese dioxide, right? Or I can just write down this in the reverse way, right? I can say that 87 gram of MnO2 reacts with 4 into 36.5 gram of HCl. Now 1 gram of MnO2 will react with how much? 1 gram of MnO2 will react with how much? 4 into 36.5 divided by 87. Now 5 gram will react with how much? 5 gram of MnO2 will react with 4 into 36.5 divided by 87 into 5. Okay, so just can calculate this value and you will get the answer. Clear? 8.4 you will get. Now what is something called as limiting reagent? Now suppose there are 2 reactants which are reacting to give you products, right? Limiting reactant is that reactant which is consumed first in the reaction. Means it is present in less amount, it is consumed in the reaction, and this limiting reactant only determines the amount of product that will form. Okay, so the reactant which gets consumed first and limits the amount of product formed and is therefore called as limiting reagent. Okay, so here a question is there: 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, so if you see here, I have this reaction. First of all, I need to write a balanced equation. Mg plus O2 gives MgO, right? Mg, so I can balance it like half O2, or let's make it's a whole number. So 2 Mg plus O2 gives 2 MgO. Now here we have 1 gram of Mg, 1 gram of Mg and 0.28 gram of O2. Okay, that is what is given in the question. Now according to the question, what happens? I can say 2 moles of Mg reacts with 1 mole of O2. Okay, according to the balanced equation. So 1 Mg is mass is 24 gram. So 24 means 48 grams of Mg, okay, reacts with 32 gram of oxygen. Now the question is asking for 1 gram of Mg. So if I have 1 gram of Mg, it will react with 32 by 48, means 16 2s are 16 3s are 0.66 grams of O2. So 1 gram of this one will react with 0.66. right? But 0.66 is not there, only 0.28 is there, right? So that means what? 0.66 will not react, right? 0.66. So oxygen is the limiting reagent, means this will finish first. So 28 gram will react, 0.28 gram of oxygen will react with manganese, and some amount of manganese will be left behind. So if you see here, we can eliminate these two options. Manganese will left behind. Now how much of manganese? You have taken only 1 gram. So 5.8 gram will not be remaining, right? 0.58 only will remain. So option number B here. Let's see the next question here. Next is your percentage or different concentration terms. This I think all of you have already studied in the solutions chapter in much detail. So just formula we can revise: mass percentage of the component is the mass of the component in the solution by the total mass of the solution into 100. Now how to calculate mole fraction? Number of moles of the component divided by the total number of moles. So for example, you have ethylene glycol. 20% of ethylene glycol is present, right? So 20% of ethylene glycol means C2H6O2, that is 20 grams, okay? And your you have it in water. So what will be the mass of water? You have 20, this means 80 grams, right? Now what is the molar mass of this one? 12 2s are 24, 30 plus 32 is 62 gram per moles. Okay, and this molar mass is 18 gram per mole water. What is the number of moles of ethylene glycol? That is given mass by molar mass, so 20 by 62, and here I have number of moles of water, and that is given mass by molar mass, 80 by 18. So now if I want to calculate the mole fraction of ethylene glycol, okay, mole fraction of ethylene glycol, that will be equal to what? 20 by 62, or let me write down the formula. Mole fraction of ethylene glycol will be number of moles of C2H6O2 divided by number of moles of C2H6O2 plus number of moles of water. Okay, so that will give me how much? 20 by 62, okay, divided by 20 by 62 plus 80 by 18. Okay, so if I solve this, you can calculate the molar mass, and that will a mole fraction 0.068. Okay, I'll just tell you the formula. Next we have molarity formula, give number of moles by 1000 into volume of the solution. So calculate the molarity of a solution containing 5 gram of NaOH in 40 grams. So given mass is 5 gram, moles of the solute, right, means W2 by M2. W2 is 5, NaOH mass is 40 into 1000 by 450, right. So if I solve this to calculate molarity, you will get 0.278. Next, molality, W2 by M2 into 1000 by mass of the solvent. Okay, so 2.5 gram of ethanoic acid in 75 gram of benzene. So we have 2.5 gram here, W2. Molar mass of this one, 12 2s are 24, 24 plus 4 28, right. C plus C, 12 12 24, 24 plus 4 28, 28 plus 32, we have 3 2 5 plus 1 6. So 60 into 1000, okay, and mass of the solvent given is 75. So if I solve this, you will get 0.556 m. Okay, so that is your concentration term. So this was a basic thing for some basic concepts of chemistry. So you just need to focus on calculation of moles and the calculation of empirical formula and the stoichiometry. Okay, so we will be doing questions on this. So I hope you can revise all these terms and all these concepts and be ready, be prepared for the question solving session. Okay, that's all students in this video, and I hope you have liked the session. All the very best, and please prepare hard for your exam. Thank you for watching, and do not forget to subscribe the channel.